Nobody's harder than me, I'm a breaker of chains, I'm living it free. Trust what I said and not what you see. Nobody keep it in order like me. I'm really a beast and I'm out in the wild. The grill in my eye and I want it right now. That's a fact.
In this tutorial, I'll show you how I did the object tracking. You can download the tracking marker Photoshop file from my Gumroad. Let's get started. Let me start by explaining how I filmed the footage. All you need is a camera to film with and a phone to track. I filmed in 4K at 60 frames per second to get the best results for motion tracking. The high resolution helps maintain the sharpness and detail of the tracking markers, and the higher frame rate makes the motion smoother, which improves tracking accuracy. I just used my OnePlus 11 phone to film, but a mirrorless or DSLR camera would be better. Next I used a phone holder to keep the footage steady. In this case we want the background to be completely still. This way we only need to track the phone and not the camera movement. When filming, there are a couple of more things to keep in mind. Try not to make any over-exaggerated movements. Even at 60 FPS, we want to avoid motion blur as much as possible. Avoid blocking the screen or tracking markers unless you plan to rotoscope that area. We'll need to do it when interacting with the screen, but otherwise it only creates extra work. Try to keep all markers in focus for the whole clip. Also make sure they don't go out of frame. Finally, it's best to avoid sharp reflections that can interfere with the tracking. There are quite a few things to think about when filming, but it's probably the most important step. If you manage to get good footage that allows for a stable track, the rest will be easy. As always, the first step is to convert your footage into an image sequence. In the video editing workspace, add your movie clip, adjust the transform if needed, set the end frame to the length you want your image sequence to be. I'll use 30 seconds of footage, which is 1800 frames at 60 FPS. Set resolution and frame rate to match your footage. Even though I filmed in 4K, I'll render out the image sequence in 1080p. That's just because it'll be faster to work with in the motion tracking workspace, especially since the clip is quite long. 4K footage downscaled to 1080p will still give better quality than filming directly in 1080p. Set view transform to standard. Select your output location. Set the output format to PNG and 8-bit. Then press Ctrl F12 to render animation. Next, let's bring the footage into Blender to begin motion tracking. Before tracking, I always open up a new Blender file. Having the footage loaded in the video editor can interfere with the rest of the process. Go to the motion tracking workspace and import the image sequence. Adjust the resolution and frame rate. Set the view transform to standard again. Press set scene frames and prefetch footage. Now go to the track tab on the right and open the objects dropdown. In previous tutorials, we have tracked a scene and solved the camera motion. This time we will track an object and solve the object motion instead. To do this, press the plus icon to create a tracking object. Now we can start object tracking. For this project, we will use Affine for the motion model. This is because it is great at tracking markers that skew or rotate a lot. Set the match type to previous frame. Enable normalize to avoid issues caused by changes in lighting. Then we can start adding tracks. Zoom in on a marker and add a track with Ctrl left click. Press S to scale it just so that it covers the whole marker. Continue to add tracks to the rest of the markers. Rescale when needed. Once all the tracks are placed, select them by pressing A, then press Ctrl T to track forward. Most of the tracks made it all the way to the end, but some of the tracks stopped because my hand got in the way. We could continue tracking when the marker is visible again, but then we lose some tracking data for the frames where it's blocked, so I'll show you another technique. Let's start with the top track that stopped. Go to the last frame before the track stops. Open the Marker drop-down menu in the right track panel. We can use the offset values to temporarily place the track at another marker. I'll move the track to the marker directly above it. Then we can hold Alt and press right arrow to track forward frame by frame. Repeat until the original marker becomes visible again. Then we can reset the offset values to 0 again and track forward from there. Now if we go back to where the thumb blocks the marker, we can see that the track continues even when it's blocked. This is how you can temporarily use tracking data from another point. And you can use this technique for any situation where a feature gets obstructed. Let's continue to do this for the other tracks that stopped. I'll move this next track towards the marker to the left of it. Recenter the track if needed before tracking forward again. This track starts to shift away from the middle of the marker during the last 2 frames. So I'll go back 2 frames and delete them with clear track path. Then I'll offset the track starting from that frame instead. The same thing happened to this track, so I'll clear the last frame and then offset the track. At first I was going to shift the bottom marker to the left, but vertical alignment felt safer. I figured it might help avoid perspective issues if the phone tilts. I'll not bother offsetting the last track, because the thumb crosses it over and over again, and I think we can get by without that data. Instead I'll just recenter it and track forward every time it becomes visible again. You can also track forward until it stops with Ctrl-T. Just make sure to clear any frames that start gliding away. Now that we've finished tracking all of the markers, let's solve the object motion. Go to the Solve tab. Since we're tracking the object motion and not the camera motion, Blender can't calculate or refine the camera information for us. That's why these options are grayed out. Let's first try to solve the object motion without making any changes. Our solve error is quite high at the moment. Below 1 is usable, below 0.5 is good, and below 0.3 is excellent. There are a couple of ways to improve the solve error. Enabling tripod could help in situations with limited camera movement. However, in this case it just made it worse. Enabling keyframe lets Blender automatically choose 2 reference frames for the initial solve. This can reduce errors and help it guess the scene scale. That didn't help much. You can also set the keyframes manually using keyframe A and B. Try setting it to an interval with a lot of perspective change. This can help Blender better understand the object's motion and scale. I'll set it to frame 250 and 280. That didn't help either, but we've missed one important step. Since Blender doesn't have any camera information to work with, it struggles to get a good solution. So we need to input some information manually. To do this, go to the right track panel and open up the camera and lens drop-down menus. Here we specifically want to input the sensor width and focal length in millimeters. You can search for these specifications about your camera online. I actually asked ChatGPT for it and it told me that my OnePlus 11 has a sensor width of 7.6mm and a focal length of 4mm. I input the values and try to solve the object motion again. Even if the values we input are technically accurate, they might not be calculated correctly by Blender. This could be caused by the footage's perspective, distortion, stabilization settings, digital modifications like cropping or lens correction, or the fact that I shot in 4K. In these cases, you'll have to experiment with different values. Increase or decrease the focal length and sensor size and see if the solve error improves. For example, the solve error improves as I increase the focal length. Reducing the sensor width also made it better. Blender gave me a great solve error when using a sensor width of 4 and a focal length of 6, which seems to better match the footage's perspective and processing. This can be frustrating, but is crucial for getting a good solve error. Once we have a good solve error, we can continue to the next step. Open a new window and set it to 3D layout. Go to top view and create a camera if you don't already have one. Bring it up 1 meter. Solve object motion again. This is to update the camera based on the motion tracking data. Press 0 on the numpad to enter camera view. Go to the scene setup drop-down in the Solve tab and press Set as Background. This sets the footage as the background in our camera. With the camera selected, add a camera solver constraint. Now our tracks have appeared in the camera view. If they haven't for you, make sure that motion tracking is enabled in overlays. Next, I want the camera and our object solve to fit real-world dimensions. First, I go to the camera object data properties. Under viewport display, I set the camera size to 0.15. This is 15 centimeters, which is about the size of my phone's. This doesn't change the properties of the camera, only how it looks in the viewport. But our tracks still look way too big. In the Solve tab under Object, I'll set the scale to 0.15 as well. This is to match the object to the real-life dimensions of the phone. This will ensure that materials, lighting, and physics are calculated realistically. Now we could already start adding geometry and parent it to our object track, but it's easier to model and adjust the screen if it's aligned to the world axis. We need to do this manually. Let me show you my approach. First, position the bottom middle marker at the world origin. Select it to see it clearly. Switch between views, scroll to zoom in, and try to get it as close as possible. Then set the pivot point to world origin. This will allow us to rotate the camera from the world origin. Press RX to rotate the camera on the X-axis. Switch between views again and align the tracks with the world floor as best as you can. I'll select the top middle marker as a guide. Press RY to rotate the camera on the Y-axis. Press RZ to rotate the camera on the Z-axis. The tracking solution might not make the markers align perfectly flat, but that's fine as long as the motion is planar. Select all markers in the motion tracking workspace. Under Geometry, press 3D markers to mesh. This creates an object with vertices at each track. However, the object does not move with the tracks yet. We need to add an object solver constraint. Select the object and camera as inputs. Initially, the object is aligned to the camera space. Pressing Set Inverse aligns it to the camera in world space. Now the mesh is positioned correctly again. And if we move the timeline, the object follows the markers. So we can disable motion tracking in overlays. This object can be our new screen reference. And now we can also create geometry and parent it to the object. Let's start by modeling the screen. Go to the 3D layout workspace. Create a plane. Go to top view. Move and scale the plane to fit the tracks. Set the pivot point back to median. Scale the plane along the X and Y axes to match the screen's dimensions. Go into camera view. Switch to edit mode and move the vertices for more precise alignment. Be sure to only adjust on the X and Y axes so that the plane remains flat. Switch back to object mode. Since we scaled the plane in object mode earlier, we need to apply the scale. Otherwise the bevel won't work correctly when we bevel the corners. Press Ctrl A and apply scale. You could go into edit mode and bevel the corner vertices with Ctrl B and V. but for a bit more control I like to add a bevel modifier. Set it to vertices. Adjust the amount and segments until you get a nice bevel. I think 12 segments is enough for a smooth bevel. Move the corner vertices to make the bevel fit the screen better if needed. Now I want to create the camera notch. It's a bit difficult to see the outline of it. In the object data properties, I can turn up the opacity of the background image to see it clearly. I'll use a cube as a boolean to cut a notch into the plane. Scale it down and position it to fit the area of the notch. Your phone might of course not look the same as mine, so you'll have to adjust the boolean accordingly. For example, you might only have a front-facing camera without a notch. In that case, just use a cylinder as a boolean instead. I usually use the add-ons Hardops and Box Cutter for booleans, but you can use Bool Tools instead. For this you need to have the Bool Tools extension installed. Select the cube, then select the plane and press Ctrl-Shift-B. We want to use difference. Auto Boolean applies the boolean straight away. Brush Boolean creates a boolean modifier but doesn't apply it. That's what we want. This allows us to edit the boolean before applying it. The camera notch is rounded. I like to work non-destructively as much as possible, so I'll add a bevel modifier to the boolean, but first I need to apply the scale. Adjust the amount, segments and position to fit the notch corners. I think 8 segments is enough here. However, the corners at the edges also have a smaller bevel, so at this point I think it's easiest to just apply the boolean modifier. Before doing this, you can put duplicates of your objects in a backup collection. To do this, select your objects and press Shift-D to duplicate. Right-click to cancel transforms. Then press M and move the objects to a new collection called Backup. Now we have a backup in case we want to go back and change something later on. We can disable this collection. Since I use the add-on Box Cutter, it automatically puts all my boolean cutters in a separate collection. I can make another video about these add-ons sometime. It might also be a good idea to save your project at this point. Now let's apply the modifiers. Select the plane and go to the Modifiers tab. We have to apply the bevel before we apply the boolean modifier, otherwise the bevel of the plane will get messed up. Hover over the modifier and press Ctrl-A to apply it. Then do the same for the boolean modifier. You can hide the cutter or just delete it since you created a backup before. Now I can go into edit mode and bevel the last corners. Select the vertices in vertex select mode. Press Ctrl-B and then V to bevel vertices. Scroll the mouse wheel to adjust the segments. I think 6 segments is enough here. Now the screen plane looks good, but it doesn't follow the motion of the object yet. Select the plane and shift select the tracks object. Press Ctrl-P and set parent to object. I like to use keep transforms. It basically just lets the plane store its own transforms in world space instead of recalculating them based on the local space of the parent object. And now the screen follows the plane. The plane seems to follow the motion of the phone pretty well, so I'm quite happy with this track. Alright, that's it for this video. Now you can try adding any objects you want to follow the phone. Please drop a like if this video was helpful. In the next video I'll show you how I created the backspace and a swipeable product carousel using geometry nodes. So subscribe if you want to learn more. Thanks for watching, I'll see you in the next one.